So good day. Just for fun and maybe you get some information about this. So I'm gonna I'm gonna show you how can you do a Pearson correlation test on Excel and RStudio. I find this example file on our group chat and kind of great. So the correlation test that we use here is Pearson correlation test, and I mean, it has a value between -1 and 1. So you cannot go past above that. So -1 means if your value is absolutely in -1, that means your 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 variables being compared are negatively skewed, or as far as now it's on left. And if it's +1, your variable being compared is positively skewed and is on right. Okay? So if it's 0, your the variables being compared doesn't have any relationship or correlation at all. So let's start with this. So in Pearson correlation test, you get the R value, which actually the -1 and 1, the value between all of those. And for this example, we see here that 0.709 is a Pearson correlation test, as you can see here is Pearson, between D2 and D51, which is here, class attendance. Wait, between class attendance, between academic performance rather, and class attendance. So, a little bit of tidbit here. So on RStudio, you cannot do a Pearson correlation test if the total values of your variable here at x-axis is not equal. Okay? So here, as you can see, they're all equal. They're all 50. They're all 50 values entries rather on all of the variable here, namely class attendance, class participation, motivation, academic performance. They are all 50. Means even here it would work, right? Because they're all complete. They're all the same. The value is the same. Okay? And RStudio, it won't work if it's not the same. And if it's the same, it would work. So the first example here has R value of 0.709, and there's a significant correlation between academic performance and class attendance. Another is Pearson correlation test between D2, which is motivation and class participation, and the other one is you get a point, and then they got a C value, which I don't know how they get because there's no any information about here. So with that said, that's how you get it here on Excel. You just call Pearson, and Excel would automatically decide, oh, that's Pearson correlation test, and give the data here, especially here, or column. So it starts from column D, D2 here, and ends with D51, which is here. So that give you much call those much flexibility. Okay, because on RSO you can't do that. As far as I know, you can do that on my little you can do that. So on an Excel, you can actually specify if your other data is like, let's say there are other entries here and you don't want that. We want to discard it. So we can use personalization test. We can just explicitly say that, you know what, you should just on a D51. So if there's more data outside of that, say let's say this column D has data on 52, 58, 54, we can just explicitly say that Excel, just do a Pearson correlation test from column D1 up until D51. Okay, very, very great tool. So, how can we do this? So, after Pearson, yeah, and Pearson correlation is blue and red. It gets its test, and you got the data there. So, how can you do it on RStudio? So, it was probably the same. I mean, like, it's RStudio is program language, but uh, as you know the basics, you get everything, and Google is your friend anyway. So, we will copy this file, this Excel file. It's in XLSX, and you can actually export this directly in RStudio if you have the template. I think if you have the extension, but I don't want that. I use CSV because it's much easier to do. So I make a copy of it, here and remove the result because that's not a result. If RStudio saw that, that's a outlier data. Okay, so here we have the plain CSV format of the file, example file. And what we gonna do here, so just to show you, I'm gonna delete it. We will, what it goes, we'll copy it, no, we will export it, we will import it rather on RStudio using this file. So we're gonna click file, then we will, where is this? We will import dataset from text base, then you will go to the location where it came from or where your file resides, which here is in the document and it's on CSV, and click open. And we'll ask with this, just since it is a CSV file, there's like a delimiter, string delimiter to show you how can you do it. So you can put it back again. So we'll click import and boom, here it goes. Almost the same as what you see here, without the color of course, but they're the same, almost, right? See, it's just the same. They're the same data. So what can we do with that? So just like on this example, let me exit this CSV file. We will do the correlation test. Okay. Oh wait, let me undo this thing. Yeah. So we'll do it on RStudio, and hopefully we can get the same result or near of the result rather. So what we do is we'll execute this file. I mean, it's not necessary, but I'm lazy, so I just execute all of this file, all of this library. Then we will go to the example file that I made earlier. So which is this. So this is a correlation test. Let's start with the core test. That's the correlation test. That's short form of correlation test. And we give it a location. Oh, hey, RStudio, go to example.ho here, which is actually that. And here's your location. Go to the example.ho and give the variable 1 an assignment, which is the academic performance, which is that here. And now do it another. Go to example.ho again and assign class attendance to the other one, and the correlation test that we would be using is Pearson. And now I'm gonna click enter to execute the code. Boom, we got the correlation, we got the answer. So let's start with this. So data example, person product moment correlation. So you get 3 values first. So this is the t-score, which is 6.9628. You can round up to 7 if you want. It's very easy. And you have the DF value, which is 48, and a p value of less than 0. So if you get e minus 0.9, that means it's statistically significant, because we are targeting 0.5 at least. If it's higher than that, it's not, right? Don't take my word for that. And we have 95% confidence interval. That means 95% of our data are between 0.5, 0.53 and 0.82. And now we have the correlation, oh my god, the Pearson score, or the R value, which is 0.7086959. So wait a second, you ask, that's 0.709, right? 709, that's 0.709. And well, just round it off, 708, just round it off and it becomes 0.709, right? You can just do that by adding some rounding off function. So let's check first, right? So let's check. We'll now go to the other one. So we will gonna check if RStudio can do it too, which actually can do. So first here, 0.6. The second is 0.645. There's a significant correlation on that, of course, which is between D2 here again versus academic performance versus class participation. So we're gonna do that on RStudio. So that's class participation. So we'll just do this. Class, we'll list attendance and replace it with participation. Participation. And of course, there's a possibility that I type it wrong. Wait, oh my god, yeah, there's no T on that. And click enter. Boom. execute it, and we got 0.645 value again here. And that is the same as the Excel do. Then we'll continue on that, and we'll do the other one, which is again academic performance versus motivation. So we'll just do that again, remove this, and just do the motivation. And enter. Boom, 0.4344 on here. Okay. And that is 0.34. Nice. So as far as I know, as far as I'm concerned in this example, so researchers trying to draw a correlation between academic performance, which are in the independent variable, and its dependent variable. I know, which is the dependent variable, and its independent variable like class attendance, class participation, and motivation. And looks like they do it. That's how they find it. So there's a significant correlation on that. We can continue on creating a chart, but that's another time for another day. And that's how you do it on RStudio. So the question would remain like, what should I use? Should I use RStudio or Excel? It depends on you. They're probably both fine, but it depends on what you're doing. So if you're doing large file, large data set, big data this, I recommend using RStudio. But ouch. But if you're just doing this like what, 50, like that is 50 data set, that's 5, that's 200, you're better off with Excel, because RStudio is a bit complicated. I mean, like, there's a steep learning curve on this thing, because it doesn't look like Excel. I mean, like, yeah, it kind of looks, it is, but it behaves like Python. What? Yeah, it behaves like a programming language. It behaves like a program in itself, right? I don't know if you get what I mean. It's an IDE, to be honest, an integrated environment. So it's used for coding. But if your data is large, you should use this, right? But if your data is like, I don't know, maybe if your data is less than 5,000, if your each variable is less than 5,000, that's 20,000, you're probably better off with Excel. But if your data is large, like 10,000 or more, or maybe even like 100,000, you should use RStudio. RStudio is made to handle those files. But if you're just for fun, you can use RStudio too, and you can use Excel. So the advantage of Excel, of course, everyone almost knew it. Like, if you don't know Excel, are you living on a rock? Right? Like, this is a very basic competency now that you should know how to even use Excel, even basic. So most people knew it. Most people knew how to use it. It's very easy. The learning curve is not that large. It's not that great, rather. But it's not really perfect solution. And if you like to explore, you probably have better time using RStudio, especially if you have more mathematics involved and you don't want to deal with them. And that's the person like me. I don't want to deal with margin of error calculation, getting sample mean. You can do this on a scientific calculator. You can even do this on a normal calculator, but that's very complex. And we as humans, me as personally, I don't want to do that. It's very cumbersome. And I hate math, right? So I kinda hate math, but I kinda like programming, so I find I have middle ground on that. So that's it. That's about it. So that's how you do both these things on a very different application. But if you want to use both of them, it's fine. And that's all about. And thank you for watching.